Alrighty, so for topic 2, we are still solving a quadratic inequality, but this time, unfortunately, it is not factored for us. So we're going to have to do a couple more steps for these examples. So now let's look at example 1. So let's look at the directions first. It says graph the solution to the following inequality on the number line, and then write your answer in interval notation. So example 1, we're given x squared less than or equal to 2x. So we're going to use these steps. So for step 1, it says rewrite the inequality so that one side is 0 and the coefficient of the leading term is positive. Then factor. So when I look at this, there is no 0 on either side, so we're going to have to move some stuff over. How am I going to decide what to move over? We're going to look at the leading coefficient. Okay, what is the leading coefficient? It is it's the coefficient of our leading term. So the leading term is the one that has the highest degree, which is over here is x squared. So over here our leading term is 1, a positive 1. So since it's a positive 1, I know we're going to subtract 2x from both sides. So it's going to be x squared minus 2x less than or equal to 0. Right? So now, also part of step 1, we want to factor. So I have x squared minus 2x. They both have an x in common, so we're just going to factor that out. And we're left with x times x minus 2 less than or equal to 0. Now that we're done with step 1, we're going to move on to step 2. So step 2 is to find the boundary points of the inequality. How are we going to do that? We're going to kind of just, so when I talked about like doing the zero product property and I said let it equal 0, those are just extra steps. If you want, you can just go ahead and, so finding boundary points. Okay, I do want you to specify when you are finding the boundary points, right? And so when we do that, you can just, instead of just letting it equal 0, you don't have to do that. You can just tell me, you can just use the zero product rule right away. I don't care. Okay, so it can just automatically say that. So then we know, so x is 0, that's already solved for us, or x is equal to 2. And these are our boundary points. So in the first example, so the topic 1 example, I gave myself 2 number lines. However, I realized that we're not always given the luxury of having 2 number lines. So for my test point, what I'm going to do is I'm going to draw the test line, the test and thing myself. Okay, so remember we have to have the arrows because they're going infinitely both ways. And what are we going to do? So after we draw this line, now we're going to plot our test point, or our boundary points. So it's going to be at 0 and 2. Okay, you don't need all that -10, blah, blah. You just need to write down the boundary points. Okay, the horizontal line, pretend that's even, pretend that's straight. So now what are we going to do? So this is interval 1, interval 2, and interval 3. So now what we're going to do is we're going to pick test points. So over here, what is a number less than 0? So we have the option from -infinity to 0. I'm going to pick, so let's pick x is equal to, I don't know, -10. Over here, we don't have that much of an option. We have to pick something between 0 and 2. We'll pick 1. Okay. You can also pick 1/2, 3/2. You can even pick like 16, 16 15. Doesn't matter. But normally we pick whole numbers because fractions are gross. So, and then for the third interval, we have to pick something between 2 and infinity. So over here, I'll pick x is equal to 5. Right? So what are we going to do with these values? We're going to plug it into our original inequality and then solve. So it says original, but I'm going to use this one. Okay? These two are equivalent. Right? So the only way that you can use this, so because I think they say use the original inequality because it is full, like it's already given to us. We're not solving for anything. But as long as we double check our work, it is fine. So if I redistribute this, I get x squared minus 2x. Okay, so I go back to the second line. And then when I add 2x to both sides, I get x squared less than or equal to 2x. So when I work backwards, I'm still getting my original inequality when I solve for this one. So that's how I know this is equivalent, so I can use this. Right? So, but in order to use it, you have to check it. Right? So let's check for x is equal to negative 10. So checking points. So x is equal to negative 10. I'm going to put, so negative 10 times negative 10 minus 2. Is this less than or equal to 0? So this becomes negative 10, and this is negative 12. Negative 12, is this less than or equal to 0? A negative times a negative, that is a positive. Okay, so and this is not true. So one thing I want to say, so when we check points, so essentially we don't care about what number it is, we just care about the sign. I just know usually students like it when you just solve it outright. But one thing I do want to just kind of add, so if I had, so rewriting the same exact thing, if I had this, all I care about is the sign. So over here, I don't have to solve for anything, so this is just a negative. And negative 10 minus 12, that will also give me a negative. I know that when I multiply a negative by a negative, I get a positive. Is a positive number less than or equal to 0? No. Okay, so because it's not, this is not included. This only works if you have 0, if you're doing 0. Okay, because it's easy to tell what's negative and what's positive, as opposed to, like, if we use the x squared less than or equal to 2x, we'd have to actually plug in the values because you never know. Right? So what do we get from this? This is not included. Okay. So now we're going to check when x is equal to 1. Let me bring this down a little bit. So again, we're using this one. So we have 1 times 1 minus 2. Is this less than or equal to 0? Okay. So if I want to use this one, so these are small numbers, so it doesn't really matter, but you can still do positive times negative. Okay. And then positive times a negative is a negative. So a negative number is always less than or equal to 0, so this is included. Okay, if you don't believe me, let's just solve for it. So we have 1 times negative 1 is less than or equal to 0. 1 times negative 1 is negative 1, which is less than or equal to 0. Okay, so both these methods are the same. Well, not the same, but it'll give you the same answer. So lastly, we got to check our final point, which is x is equal to 5. So we'll have 5 times 5 minus 2. Is this less than or equal to 0? This down. So we have 5 times 3. Okay, 5 times 3, that is a positive 15. Okay, which is not less than or equal to 0. So what does that tell us? This is not included. So the last thing we have to do is we have to do step 5. It's just test the boundary points. So what I said last time is that if it's strictly less than or greater than, put an open circle, don't have to test it. Okay, because it's not included. But when it has less than or equal to or greater than or equal to, we should just check our boundary points, just in case that they will be undefined somewhere. So yeah. So one thing I do want to note is that because this is a polynomial, the domain is all real numbers. So it's from negative infinity to infinity. There is no breaks in it, like there's no restriction to the domain. So we could just color in the boundary points and call it good. But I do want to make the good habit to test the boundary points in case you're ever given something like, I don't know, like x squared minus 2x over x. Okay? Because in that case, 0 could not be a boundary point because 0 makes this function undefined. All right? So, yeah, just check. So when we do check, so check in more. So if we have, if we plug in 0 for x, we get 0. So if we have x is equal to 0, we'll get 0 times 0 minus 2. Is this less than or equal to 0? Negative 2 is less than or equal to 0. So this boundary point is included. The last thing we're going to check is when x is equal to 2. So we'll get 2 minus 0. Is this less than or equal to 0? Right. Okay. And then when we do that, we get 2 times, copied that wrong. This is 2 minus 2. Okay, so this is 2 times 0. Is this less than or equal to 0? 0 is equal to 0. Okay, so it satisfies this inequality. So that's how we know that the boundary points are included. All right. So now the final step that I failed to write is we have to graph our final solution. So this is what the fancy graph's for. So that we're going to use it to graph. So we're going to look for 0, okay, and we're going to look for 2, right? And now we're going to, so for the first interval, not included. Second interval, it is included, okay? And then the third part of the interval is not included, okay? So this is our final solution. Before we're done, we have to do one more thing. So our directions say we also have to write it in interval notation. So what is this in interval notation? Okay, remember we're going to start from left to right. So we go left, there's nothing, 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 nothing. Boom, we hit a wall, it's 0. Okay, we keep going. And then we notice it stops at 2. Okay, I'm putting brackets because these are closed circles. So they're included, and then we keep going, and there's nothing left. So this is our interval notation. I'm going to take it a step further, and I want to do set notation. So what is this? This is the set of all x such that where x is going to be between 0 and 2, where they're both included. Right? So I know that solving inequalities, like even quadratic inequalities, can be a little tricky. So I decided we're going to do another example. So our next example we're going to do is negative x squared plus 6x less than or equal to 5. So what's the first step? The first step is to get one side equal to 0 and make sure that the leading coefficient is positive. So I look at it, neither side is equal to 0, so we're going to have to move some terms around. How do I know which terms to move around? I'm going to look at the leading term, which is this one, and I'm going to look at its coefficient. The coefficient is -1. Since it's -1, so since it's less than 0, it's not positive, I'm going to move these two terms to the other side. So I'm going to add x squared to both sides, and I'm going to subtract 6x from both sides. So when we do that, what do we get? We get 0 is less than or equal to x squared minus 6x plus 5. You can also, so this is a little note, you can also, if you want the 0 to be on the right-hand side, this is x squared minus 6x plus 5 greater than or equal to 0. So you just read it from right to left. And then if you go from right to left, you'll see that's going to be, you would read it as greater than or equal to because it would be facing, it's facing the one with multiple terms. Right, so those are the exact same. I'm just going to work on the left one. I'm just going to erase this one. Okay, so just don't worry about it. Okay, and now we can't just solve for this. Okay, so we actually, we need to factor this. Okay, so what are we going to do? So this factors into x minus 5, x minus 1. Now we're going to find boundary points. Okay, when I do that, so I'm going to use the zero product property. So we have x minus 5 is equal to 0, or x minus 1 is equal to 0. When we do that, we get x is equal to 5 and 1. Okay, and these are the boundary points. Okay, so what are we going to do with these boundary points? We're going to plot them on a number line. So we're going to draw a number line. Okay, I'm going to use my handy tool. Okay, and I'm just going to plot the points. So I have 1 and then 5. Okay, I know this is 5, 1. Make sure when you plot them, you have to go from least to greatest, right? So 1 is smaller than 5, which is why I plotted it first. So what are we going to do with these numbers? We're going to make an interval. We're gonna separate these into 3 intervals. So this is interval 1, this is interval 2, and this is interval 3. Okay. So the first couple times I did this, I just picked all the test points first and then solved. This one, I'm going to focus on one interval at a time. So maybe it'll give you an idea what you would like, what you like better. So again, I'm going to do different colors. So let's see, I'll do purple for the first one. So for this one, I need to pick a number between negative infinity and positive 1. So I notice 0 is in that interval, so I'm going to pick 0. So I'm going to test points. Okay, so this is x is equal to 0. When I do that, so I'm going to plug it into this one. Why can I do that? Because if I FOIL this, I get x squared minus x minus 5x plus 5. When I add minus 5x and minus x, I get negative 6x. And then if I wanted it to make it look like this, I'm going to subtract x squared over and then add 6x over. And then we can see that it would still be the exact same. So we can use this because it's equivalent. So I have 0 less than or equal to 0 minus 5, x minus 1. Okay, so is 0 less than or equal to? So this would be a negative number. Oops, this is 0. And this is a negative number. Negative numbers give us positive numbers. Is a positive number, so is 0 less than or equal to a positive number? Yes, it is. So this is included in our solution. For the second one, so we need to pick a number between 1 and 5. I'll pick 3. Okay. So when we do that, we have x is equal to 3. So then we're going to ask, is 0 less than or equal to 3 minus 5, 3 minus 1? When we do that, so 3 minus 5, this gives us a negative number. 3 minus 1, that will give us a positive number. Positive times a negative is a negative. Is 0 less than or equal to a negative number? No, it is not. Okay, so what does that tell us about interval 2? Interval 2 is not a part of our solution. So lastly, we have to do one more interval. So we still have to do interval 3, and we have to pick a number between 5 and infinity. So whatever you want, I'll pick 6. Okay. So when x is equal to 6, we have, so is 0 less than or equal to 5 minus, 0 less than or equal to 6 minus 5, and then 6 minus 1. Right, so 0 less than or equal to 6 minus 5 is positive, 6 minus 1 is positive. Positive times a positive is a positive. So is 0 less than or equal to a positive number? Yes, it is. So what does that mean? That means this third interval is included in our solution. Right? So lastly, we have to test our boundary points. So because our sign is less than or equal to, we should check it. Right? I'll let you guys do that on your own. So, and I can safely tell you these are included. Right? So one thing, I understand testing can be a lot. So if you do get the or equal to part, but if you tell me, if you specifically tell me, so you can say, if you say x squared minus 6x plus 5, okay, hold on. Okay, let me reword this. If you say that the domain of, and then whatever polynomial you have is negative infinity to infinity, or you can say if it's all real numbers, so the boundary points are included. Okay, if you can tell me that the domain, if there's no restrictions in the domain, then you can just plot the points. Okay, if you think that if that itself is too much, then you gotta plot the points. All right, either or, I'll accept either. All right, so now, because our domain is since it's a polynomial, the domain is all real numbers. So what does that mean? Our boundary points can be included, right? So don't mistake this, so the domain of this, don't mistake this for our inequality where it's greater than or equal to, okay? Because this is false, right? As you can see, it's not true. There's a big chunk right here that is missing, right? So you cannot include this inequality. Okay, so essentially when we're doing, what we're finding is the domain, because these are all the x values, we're finding the domain of our inequality, all right? So if you say that our inequality's domain is all real numbers, and it's not, then it's false, right? So, what do we do? So, let's see, we're going to plot our boundary points, which is 1 and 5. Our first interval is included, our second interval is not, and our third interval is included. Okay, so this right here is our final graph, right? So, and then now we want to do interval notation. So what is the interval notation? We're going to go to the left, so as we can see, it's already like it's being colored, so it's going to be negative infinity. We're going. We notice that there's a stop at 1. The 1 is included because it's colored, so it's going to use a bracket. And I keep going, so it's empty. But then I notice that more stuff is included. So what does that mean? It's going to be 2 intervals. So since it's 2 intervals, we got to combine them with the union. And this becomes 5 to infinity. And this is our interval notation. Taking it a step further, what is our set notation? Our set notation is a set of all x such that x is less than or equal to 1 or x is greater than or equal to 5. All right. So one last thing I want to say before I end this video is, so we're just graphing this, and you're probably wondering, but I thought it's a parabola. Yeah. So when we're doing quadratic inequalities, remember what this note says. It's asking for what values of x is a function positive or negative depending on the inequality. So what is this interval notation saying? So this less than or equal to, it's saying that when we graph this, that we're saying that that our graph is negative right here. So essentially, very, very, very rough graph. Okay. Essentially, it is like essentially like this is where our graph is positive. Okay, and then it's just negative all the way down. Okay, that's what this means. This color interval, it's saying these is the time when our graph is negative. And same thing for this example. This example, we want to look when it's strictly less than or equal to 0. So essentially, this is saying that this is when our graph is below the x-axis and everything else is above the x-axis. Right? So that's what this means. So, and then that's why we're just looking at the x-axis and not the y-axis.